Hello there. Today we are looking at the notes for section 4.4, and this is about side, 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 side angle side, and hypotenuse leg, all to prove that triangles are congruent. Okay, so the first method that you can use to prove triangles are congruent is side, 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 which means that you have to prove that that three sides on a triangle are congruent to three sides of another triangle. That's what the side, side, side postulate is. Okay, so we're going to start out by doing two things. We're going to make a list of the sides that are congruent, and we're also going to mark on only one of the triangles the pieces that we have so that it's easy to see how we have side, side, side. Okay, so let's start out on triangle ABC. Side AB on the first triangle is congruent to side DE on the second triangle. Side BC on the first triangle, so we have one side. Side BC on the first triangle is congruent to side EF on the second triangle. And I know this because they have the same number of tick marks on those sides. Side AC has 3 tick marks, and so it is congruent to side DF on the other triangle. Okay, now I neglected to mark these, but I had a set of sides and another set of sides. So when you get to the end after you've marked your picture appropriately, you can see that the method that we're using to prove that these triangles are congruent is side, side, side. So a set of sides, a set of sides, and a set of sides leads me to believe that triangle ABC is congruent to triangle DEF by side, side, side. All right, let's look at the next method. This method is called side angle side, and it says if two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the two triangles are congruent. Now that word included, where it says included angle, just means that the angle has to be between the two sides that you know. So I'm going to start out with that angle, right? So angle X and angle W are congruent. I'm going to mark that I have an angle. And I'm going to write on the list over here that angle X is congruent to angle U. Okay, then we have a set of sides here. XY is congruent to VU. And XZ is another set of sides that's congruent to UW. All right, so then I can conclude that, I'm going to zoom out just a little bit so you can see better. I can conclude that triangle XYZ is congruent to triangle UVW by side angle side. It's really important that this angle is in between the two sides that you know to be proving things by side angle side. All right, last one for today is hypotenuse leg. Hypotenuse leg theorem says if the hypotenuse and a leg, another side, of hypotenuse and a leg of one right triangle, now this has to be a right triangle. In fact, this is only for right triangles, are congruent to the corresponding parts of another right triangle, then the triangles are congruent. Okay, so the very first thing that you have to recognize is that this has to be a right triangle, because only in a right triangle do you have a hypotenuse. So what's nice right here is that across from the right angle, we have a set of hypotenuses that are congruent. So AC is congruent to EF. And of course, those right angles are the same. So we have angle B is congruent to angle D, and I'm only writing that down because I need to know that that is a right angle. And then lastly, AB is congruent to ED. Now, because we have a hypotenuse, we're not calling this a side, we're calling this a leg. So ED. So I can conclude that triangle ABC is congruent to triangle EDF by hypotenuse leg. Okay, now let's look at a couple of examples. They've given us sets of triangles and they're asking us, are they congruent? And if they are, what rule would make them congruent? Okay, so I've got two triangles here, and I'm going to go ahead and highlight one just so you can tell the difference between one and the other. So on one triangle, I have a set of sides that's congruent to a set of sides on the other triangle, and I have another set of sides here. It's congruent to that side. And then this is a freebie. This is one that you don't always think about. But these two triangles actually share a side, and this is actually called the reflexive property, where something is equal to itself. So by the reflexive property, you can say that this side is the same, and then the other two sides are marked. So yes, they are congruent by side, side, side. All right, let's look at this next one. Oh, you know what? There's another freebie on this one. I think of that reflexive property as a freebie that you can mark. The other freebie that you can mark is vertical angles. Look at that. Oh, I have a pair of angles right there. I have a set of sides that are congruent and another set of sides that are congruent. So yeah, this set of triangles is also congruent by side angle side. All right, now this is two right triangles. So right away I've got to check and say to myself, okay, well, I see a right angle there and there. So I know I've got that angle. And directly across from it has got to be that hypotenuse. Got that there as well. And then another side, which in this case we're going to call it a leg. So yes, these two are congruent by hypotenuse leg theorem. The last one has a set of angles that are the same, right? That's one arc on that angle. There's two arcs on this angle, so I have another set of angles. And then this angle has three arcs, just like this angle has three arcs. So I've got angle, angle, angle. Unfortunately, that doesn't prove congruence. It only proves similarity. This could be like a 5 centimeter triangle, and this could be like a 5-meter triangle. So maybe just not drawn to scale. We don't know enough about these triangles to say they're congruent. So we're going to say not congruent, only similar. Okay, let's look at that next page. All right, so when you're proving things in geometry, a lot of times what you'll use is something called a two-column proof. The two-column proof tells you what you know and how you know it, or why you're able to say that. So in this proof, they've given us some information. It says W is the midpoint of TV. And look, that's one of the things that we know. And the reason that we know it is because it was given to us. So that first blank is going to say given. And then next, it says also angle UWT, where's that at? UWT, right here, is congruent to angle UWV, right there. And that's also given to us. So that's already been written here on our paper. Now let's go back to this midpoint, right? If something is a midpoint, we'd want to mark that on our paper, right? So if W is the midpoint of TV, then I would want to mark that these two segments are congruent because that's what a midpoint does. It divides a segment into two equal parts. Oh, that's actually a side, right, of each of these triangles. So I can say that TW is congruent to WV by the definition of a midpoint. So because this is a midpoint, these two segments are congruent. That right there is our midpoint. And then I've got these two angles that are congruent, right? So I've got a side already, and I've got an angle. Oh, the reflexive property. Oh, that's where triangles share a side. So I can mark an S right here. And what I can do is I can say that UW is congruent to UW. That segment is congruent to itself. And so that's a side. Oh, look at that. Side, angle, side. It doesn't always happen in that order, but this time it did. Triangle UWT is congruent to triangle UWV by side, angle, side. Perfect. Okay, let's look at one more problem. They asked us to plot this triangle, and I've already done that for us. So it's triangle PWX, and then it asks us to complete the congruency statement. So what I've done is I've went ahead and counted how many units are here, and I've got 4 units for AB, but I also have 4 units for WP. So right there, I've got a side. I've got 6 units for WX, and I've got 6 units for AC. So those two are another side. And then this is a right angle. So I've also got an angle. So I can say that ABC is congruent to WPX by side, angle, side. All right, have fun with those practice problems.